All right, guys, so this is where we left off yesterday on inverse variations. So this gives us more details on inverse variation. So this tells us when a relation between x and y is in an inverse variation, we say that x varies inversely as y. So the way that, or the reason that they're wording it that way is that, or no, there's no reason for that wording, but just know that x varies inversely as y, and they can be interchanged in, since they vary inversely, they can be interchanged in the functions, right? So did I have you guys write on the notes, on the left side of the notes, did I have you guys write these equations, the y equals k over x,
Yeah.
x equals k over y, and x, y equals k? Okay, great. And then just remember that the variable k represents the constant of variation. So the constant of variation is going to be the product of x and y if it's constant, right? Did we do this example yesterday? Okay, so this is where we're going to start off today. This says in an inverse variation, x equals 10 when y equals 3. Write an equation to represent the inverse variation, and then find the value of y when x equals -6. Right? So ultimately what we're looking to do is we want to find the value of y when x equals -6. But first we need to figure out a couple things, right? To figure out the value of y, which equation can we use? Misael?
Y equals k over x.
Y equals k over x, right? We know what x equals. X equals -6. What are we missing? K, right? How can we figure out what k is? Misael? X times y equals k, right? So you can use any of the functions to figure out what k is. But the easiest one is going to be x times y equals k, right? Because you could just do, we already know what in one pair, what x and y are, right? So we would do x times y equals k, and you get 10 times 3 is k, right? So what's 10 times 3? 30, right? So then k is 30. So now when you're rewriting the function for y, how are you going to write it when x equals -6? Misael?
Y equals 30 over -6.
That's correct, right? Because remember, we're using y equals k over x. We're going to be using the workbook some days, and some days I'll have worksheets for you guys. But we're mostly going to be working out of the workbook. All right, so remember I told you guys that we have to set it up as y equals k over x, right? They solve for k using that function, because you can use any of the functions to solve for k, right? But we took the easier way out of x times y equals k, right? But they still got the same solution for k. And then it says after solving for k, write an equation for the inverse variation. Again, we're using y equals k over x. We identified that k is 30. So now we have y is equal to 30 over x. And then just like Misael said, since we know what x is, we write this as y equals 30 over -6. And then you just divide 30 by -6 and you get y equals -5. So when x equals -6, y equals -5 in this inverse variation. Does everyone understand how we got that? Pretty simple, right? All right. If you opened up your workbook to page 176, this example is example number 2. So go ahead and do this in your workbook. It shouldn't take you very long. All right, did anyone figure this out yet? All right, so first let's look at A. Well, first this tells us in an inverse variation, x equals 6 and y equals 1/2. What is the equation that represents inverse variation? So which function are we using to solve for this? Hudson?
Y equals K over X.
Y equals K over X. Did you solve what K is?
Yeah.
What's K?
3.
3, right? So then we're going to use Y equals 3 over X, right? We're going to check the answer. The equation that represents the inverse relation is Y equals 3 over X, right? And then the second part was, what is the value of Y when X equals 15? So does anybody know what the value of Y is when X equals 15? Hudson?
1/5.
1/5, right? Did everyone else get that? Y equals 1/5. And that's correct. So we know that X is 15, right? So we would have Y equals 3 over 15. And then 3 over 15, we're just going to simplify it, right? They're both the numerator and the denominator are divisible by 3. 3 divided by 3 is 1. And 15 divided by 3 is 5. So we get Y equals 1/5. Does everyone understand how we got that? All right, great. So next we're going to be modeling using an inverse variation. Please do not get confused by this. It's the same problem that we're doing. So just don't get confused by it. They're going to change the variables. So instead of X and Y, they're going to use S and F, but it's still the same thing that we've been doing, right? So this says on a guitar, the string length S varies inversely with the frequency F of its vibrations. Then it tells us that the frequency of a 26-inch E string is 329.63 cycles per second. What is the frequency when the string length is 13 inches? So which equation, how can we set up the equation to solve for this? What equation can we use? In terms of Y and X, which equation can we use? Which equation have we been using? Y equals K over X, right? So in this example, let's say S is Y and F is X, right? So then that would be S is equal to K over F, right? So now it tells us they're using that, right? S is equal to K over F. So in the first pair that they give us, they tell us that the string is 26 inches and the frequency F is 329.63. If you want to solve for K, you just multiply the two numbers, right? You can use XY is equal to K, or in this example, SF is equal to K, right? Because that's what you're doing here. You're going to multiply both. In this example, that the way that they set it up, you're going to multiply both sides by 329.63, right? It's the same thing as doing XY is equal to K, right? So when you multiply 26 by 329.63, you get 8,570.38. So that is our K value, right? So now we can rewrite this function as, how can we write this function now that we know what K is? S equals what? It's the same way that we've been writing the other functions. We're just going to write the K in, right?
Yeah, so S equals 8,570 over 13.
So over F, right? But we're trying to figure out what the frequency is, right? It says, what is the frequency when the string length is 13 inches? So then it's going to be 13 is equal to 8,570.38 over F, right? S is equal to 8,570.38 over F, right? And we know that the string length is 13 inches, right? Because that's what we're trying to solve, what the frequency is when the string length is 13 inches. So you're going to substitute 13 for S. And then you're going to multiply both sides by F. You have 13F is equal to 8,570.38. Then you divide both sides by 13. and you get f is equal to 659.26. Any questions on that? So then the frequency of the 13-inch string is 659.26 cycles per second. Does everyone understand how you do it? It's the same thing that we did in the previous examples. It's just in a word problem and they're using different variables, but it's the exact same thing, right? It's not any more complicated. All right, so this next example you're gonna do on your workbook on page, at the top of page 177. Or, yeah. Yeah, the top of page 177, you're gonna do this on your own. So I'll give you guys a couple minutes. And just as a hint, these are inverse variations, meaning that X and Y are proportional. So it doesn't matter which value you're using for X and which value you're using for Y, as long as you stay constant. So if you're gonna replace X with the temperature, you're always gonna have your temperature as X, right? Or if you're gonna use Y as your temperature always has to be Y, right? They can interchange because they are because they're proportional. So it doesn't matter how you write it. You're gonna want to get used to writing Y equals K over X. So just use that function or that equation and then replace the numbers that you have in this problem. So I'll give you guys a couple minutes. It shouldn't take very long. All right, did anyone get the answer yet?
Is the answer decimal?
It is. What'd you get?
The 13.3 repeat.
Yep, 13.3 repeating. Did everyone else get 13.3 repeating? 1.3? 20 times 20 is 400. Did you do 40? So everyone got 13.3 repeating as the answer? All right. And that is correct. If you didn't understand how to do it, I'm going to show you guys how to do it right now. So the first pair that they gave us, they told us that when the temperature was 20 degrees Celsius, it took the ice cube 20 minutes to melt, right? Now we want to know how long it'll take the ice cube to melt if the temperature is 30 degrees Celsius, right? So we're going to use Y equals K over X. Yes. Okay. Yeah. Yeah. Yeah, sure. Yeah, I could use help. Yeah. Okay, great. Yeah, thank you. So we're going to use the function Y equals K over X. And again, the reason that we want to use y equals k over x is because we're getting you guys ready to graph these types of functions, and they're going to be in terms of y, right? All right, so we have y equals k over x. And again, like I told you guys, you can use y as a temperature variable, or you can use x as a temperature variable. It doesn't matter which one you use, you're going to get the same answer, because since this is an inverse variation, you're going to, they're proportional. So what did you guys use as the temperature variable? Did you guys use y or x? Michelle, what did you use? You used x for the temperature? What about everyone else? Sam, what did you use?
I didn't use that.
Oh, you didn't use that? Okay. So Michelle used the temperature variable x. This time I'm going to use the temperature y, just to show you guys that either way it works, right? So I'm going to put 20 degrees Celsius is equal to k over 20 minutes, right? So to figure out what k is, I'm going to multiply both sides by 20, right? I want to get rid of this denominator. So times 20 gets rid of that, times 20, and I get k is equal to 400, right? So y is equal to 400 over x. So I'm using y as my temperature variable, right? So now they're telling me that, or I'm trying to figure out how long the ice is going to take to melt when it's 30 degrees Celsius. So I'm going to replace y with 30 because that's my temperature variable. Y is equal to 400 over x. I'm going to multiply both sides by x, right, to get rid of this denominator. And I get 30x is equal to 400. Divide both sides by 30. And then 400 divided by 30 is 13.3 repeating. So the time that it takes for the ice cube to melt when it's 30 degrees Celsius is 13.3 minutes. So does everyone understand how to do this now? Make sure you understand the word problems, because there will be word problems on our tests moving forward. All right. So this was 13.3. We got the correct answer. All right, let's move on to the next slide. So now we're gonna start graphing. So this tells us to graph the reciprocal function, and then this asks us, how do you graph the reciprocal function y equals 1 over x? So everybody grab a graphing calculator if you don't have one. There's an on button on the, yeah, there you go. Oh, that one must stop. Here. Oh, wait, this is mine. Yeah, I think this is the one. So I know that the students that have been here since first semester know how to use a graphing calculator. For those that came from e-learning, do you guys know how to use a graphing calculator? Okay, so I'm gonna give you guys a quick tutorial for the stuff that we need today. All right, so first of all, the first thing that you're gonna do, if you didn't figure it out yet, to turn it on the bottom left corner, there's the on button. All right, so then when you turn on your calculator, you're gonna be in this blank screen right here, right? So we want to use this to graph right now. So right now we're trying to graph y equals 1 over x. So in order for you to graph, you're going to click on the top left corner, the y equals button, and it'll bring you to this menu right here. If you have anything on your next to y1 equals, just click the clear button right here under the directional arrows. Just click clear. So everyone should have a blank screen like this, y equals, and then nothing, right? So the important things to know right now are where the X is. So this right here, the X, this button right here will populate X into the calculator, right? So if you're ever, and you're always going to use X as your variable and on the calculator, right? So what are we trying to graph? Y equals 1 over X, right? So to do that, we're going to do Y equals, and then we're going to put 1 divided by, and then you're going to click the X button. So it should look like this, Y divided by X, or sorry, 1 divided by X. All right, and then when you're ready to graph it, on the top right corner, the graph button, you're going to click that. And it'll graph the function for you. All right, and another important function of this for you guys to understand now, if you click second and the graph button again, it'll bring you to the table. It's an XY table for this function. All right, so everyone has a graph? All right, so we're going to go back to all right, so how do you graph the reciprocal function y equals 1 over x? So the first thing that we want to think about is the domain and the range of this function. So domain refers to the x values that we can plug into this function, right? Is there any values that we can't plug into this function that you guys can think of? 0, right? Why, Ian? What's that? Oh, okay, but looking at the function though. Vivian? Right. Right, you cannot divide any number by 0, right? So in this function, we have y equals 1 over x. If you plug in 0 into that function, what are you going to get? If you divide 1 by 0 on your calculator, what is it going to say? It's going to say error, right? It's going to give you an error message. You can't divide any number by 0. And since this is an inverse variation, you can also set up this function as x equals k over y, right? So for this one, it would be x equals 1 over y. So for the range, is there any limitations? Are there any limitations for the range? Or what is it, Ian? It's 0, yeah, exactly. Right, because 1 divided by 0 would give you an error. So the first thing they're going to discuss is the range. So the reciprocal function maps every non-real 0 number to its reciprocal. All right. So here it tells us domain x does not equal 0. If x equals 0, that will result in an undefined expression. So x does not equal 0. And the range cannot equal 0 either. All right, so now that we've discussed the domain, it's going to graph it for us, right? So you guys already saw this on your graphing calculator. This is what the graph looks like, right? And this doesn't look like anything we've graphed in previous lessons, right? It's very different. We have two separate graphs, right? Does anyone know why the graph looks like this? If you look at the table, you should be able to identify why the graph looks like this. Lisa? Yeah, it's an inverse variation. But what about this graph makes it look like that? What's that? Exactly, yeah. Since our domain x does not equal 0, our graph can never touch the x-axis, right? Because x will never equal 0. And that's going to be important to know when we're talking about the end behaviors of this function. because the next is gonna discuss the end behaviors, right? So this says, observe the graph of y equals 1 over x as it approaches positive infinity and negative infinity. So let's look at it. So remember, when we're talking about end behaviors, we have as x approaches infinity, what is the output doing, right? So as our x increases, what is happening to our output? It's decreasing, right? And it's going to decrease infinitely, but it is never going to touch 0, right? What about when x is approaching negative infinity? It's going to increase, right? Because it's going from a negative towards a positive. It's still in the negative numbers, right? It's still going, but it's going to get, like, the value is still going to increase, right? It's going to increase infinitely, but it's never going to reach 0. So you guys see that, right? And then here's the table to show us how that looks. So this says, as x gets larger, the denominator gets larger, and the value of the function approaches 0, right? So x is getting larger, and our denominator is getting larger, meaning our value is getting smaller, right? And it's getting smaller and smaller and smaller. But since we have 1 as our numerator, that value is never going to reach 0, right? You can do 1 divided by 1 million, and it's still not going to be 0. You can do 1 divided by 1 trillion, and that's still not going to be 0, right? It's going to get smaller, but it will never reach 0. And that is why x equals 0 is an asymptote. So an asymptote is a line that a graph approaches. Asymptotes guide the end behavior, right? So both of these lines are approaching 0, right? But they never touch it. So x equals 0 is a horizontal asymptote of this function, right? And then the next thing it says, as x approaches infinity, f of x approaches 0. The same is true as x values approach negative infinity. So the line y equals 0 is a horizontal asymptote, right? So this is a horizontal asymptote right here, y equals 0. And then next it's going to discuss, excuse me, as we are approaching 0, right? So this says, observe the graph of y equals 1 over x as x approaches 0 for positive and negative x values. So now this is referring, as x is decreasing towards 0, what is happening to our output? So as x is decreasing, so let's just look at it from 4. As x decreases from 4 towards 0, what is happening to our output, our y values? They're increasing, right? And it's going to increase infinitely, but it is never going to touch 0. It's never going to touch the y-axis, right? And what about as, let's start at -4. So when x is going from -4 towards 0, what is happening to our output? It's decreasing, right? And it's going to decrease infinitely, but it is never going to touch the y-axis. And you can see it on this, you can see it on the table here. So they start at x equals 1, and they're making it smaller, right? So x is getting smaller and smaller and smaller. All right, 1 1/10, 1 100th. And the output is getting larger and larger and larger, right? But again, this x is never going to touch, or is never going to reach 0. It's just going to get smaller and smaller, but it's never going to reach 0. But as it's doing that, our output is growing significantly, right? And then the same, they start at -1, and they're making the x value smaller towards 0. And these negative numbers are growing, right? So it's approaching negative infinity, right? So this says for negative values of x, as x approaches 0, f of x approaches negative infinity. The domain of the function excludes 0, so the graph will never touch the line x equals 0. And that line, x equals 0, is a vertical asymptote. So these two lines right here are the asymptotes. This is our vertical asymptote, x equals 0, and this is our horizontal asymptote, y equals 0. So does the graph of this function make more sense now that we've looked at the tables and the end behaviors? All right, so you guys think you can graph one on your own? and describe the domain, range, and end behaviors? All right. So we're going to graph this function. So this function is on your workbook. It's on page 177. It's example 4. So go ahead and graph this. What's up, man?
You're welcome.
You don't have anything second period?
No, I have 2 of the same classes now.
Like channel class?
Stupid, yeah.
Yeah, so I mean, you can help out.
You don't have financial algebra in another period.
No, just
Because
6 and
if you
7.
did, then I don't have full periods. So thanks, appreciate it.
I make the schedule. Yeah, I have 4 periods of financial algebra from 1st to 5th, and then 6 and 7. Or sorry, I'll do 2 honors. Think you can do that?
No. You think I can do that?
Yeah. If you apply yourself.
Oh, you buy my shirt. I'm so sorry. You're stuck with
Are
this.
they nice? All right, but you have to buy a track one.
Huh?
You have to buy a track one.
Yeah. What is it, 15?
I don't know yet. We're still working on that.
So,
If you want to grab it. Okay, so I know what you can do to help me. I mean, it's not too difficult. So I always have a bunch of kids quarantined in Algebra too. So I recorded the lessons. So you can just make sure that it's like actually recording, like what I have up on the screen.
Oh,
So just like
just whatever's up
if
there.
if it goes blank or if it's doesn't say recording or something, just let me know.
Can they hear me?
Yeah, they'll be able to hear it. I'll put it here because the reason I'm using my iPad is because the microphone here is messed up. So I have to use this to so I can capture my audio. So just, if it goes off, let me know. All right, so did anybody finish graphing it yet? No, they don't have to be super accurate. It just has to look, similar. Did you identify the domain, the range, and the asymptotes? What's that? All right. Yep. What about the asymptotes? Look at your graph, or you can look at the table. And so the asymptotes are, remember, an asymptote guides our end behaviors. So the graph is going to approach that line, but it will never touch it, right? And it's usually going to be identified by your domain and your range, right? Actually, it's always going to be identified by your domain and your range. Maddie, what days are you going to be here?
it switches up every week. I'm here 3 times a week. I still have 6.
Huh?
I still have 6.
Oh, really? They're not.
Because they won't put me in another class. So I can't switch it. They won't even give me a different teacher or anything.
Huh?
They won't give me a different teacher or anything.
Dang. What other period do you have channels?
2nd and 3rd. But at least I have lunch in between, so it's not gonna be like I'm just going back to the same thing.
All right, so did you guys graph it on your calculator? So it should look something like this, right? So what I'm using to help me guide this graph on here is, I know that when x equals 1, my output is 10, right? Because 10 divided by 1 is 10. So I know that this should be a point on my graph. And the same for -1. When x is -1, my output is -10, right? Because 10 divided by -1 is -10. So this is what the graph should look like. We're going to check the answer. And you see when x is -1, our output is -10. When x is +1, our output is +10, right? So did everyone have a graph that looks something like this?
Yeah.
All right. So Misael told us the range and the domain of this function. So the domain and the range of this function are the same as our previous example, where x does not equal 0 and y does not equal 0. Did everyone else have that for the domain and the range? If not, do you understand why that's the domain and the range? Right, in this function, you cannot divide any number by 0, so x cannot equal 0. All right, who has the asymptotes of this function? So there's 2 of them, right? Did anybody identify the asymptotes? All right, so what we're going to do is I want you guys to write down the definition of the asymptote. I'm going to go back to the page where it gives us that definition. So on page 177 in the notes section, you're going to write the definition of the asymptote, and I'm going to put it up on the board in a sec. Right here. An asymptote is a line that a graph approaches. Asymptotes guide the end behavior of a function. So write that in your notes section on page 177. Right, does everyone have the definition right now? All right, so back to our example. So we know what the function looks like, right? So this is what the graph looks like. What are the asymptotes of this function? So what point on the x-axis what do the 2 lines approach when x is approaching infinity and x is approaching -infinity? What is our output? What is it getting closer to? 0, right? So as x approaches infinity, meaning our x value is getting larger, our output is decreasing, right? And it's going to decrease towards 0, but it's never going to touch 0. And then as our x values approach -infinity, our output is increasing towards 0, but it's never going to touch 0, right? So y equals 0 is going to be a horizontal asymptote, right? What about our vertical asymptote? What is that going to be? 0, right? X equals 0, because as our x values are approaching 0, our output is increasing, right? It's never going to touch 0 though, because remember we can't have 0 as our x value, and in the same with as from -infinity towards 0, our output is decreasing, but it's never going to touch the y-axis, right? It's never going to touch right here. So the vertical asymptote here is x equals 0. Does everyone understand that? You'll be able to identify that? Remember, the asymptote is a line that guides our end behavior. And the asymptotes can change depending on what the function is, right? So I don't know how far we'll get into this, but we'll at least do an intro real quick to graphing translations of reciprocal functions. So this gives us the function graph g of x is equal to 1 over x minus 3 plus 2. What are the equations of the asymptote? And what are the domain and the range of the function? So in the notes section on your workbook, I want you guys to write this. So write f of x is equal to 1 over, here, I'll write it down for you guys. 1 over. So f of x is equal to 1 over x minus h plus k. Have you guys seen h and k before? What does that tell us? What's that? The translations, right? H and k tell us our translations. So what do you think is going to happen in this function right here? So the parent function of a reciprocal function is 1 over x. So you can write that as well. You can write parent function is f of x equals 1 over x. So how is this graph going to look different from the parent function? This should be really easy because you guys should know what the translations do, because it's the same. It still does the same thing. Vivian? Yep. So this graph, if you're starting with the parent function, you're going to shift it 3 units to the right and then 2 units up, right? So let's look at this. So this tells us to start with the graph of the parent function. F of x is equal to 1 over x. And then recall that f of x plus h translates the graph of f of x horizontally. And f of x plus k translates the graph of f of x vertically, right? So the transformation of q of x is equal to 1 over x minus h plus k shifts the graph of the parent function h units horizontally, and then shifts the graph k units vertically. So you guys see the shift, how it's shifting? It just shifted 3 units right and then 2 units up. And the same happens with the asymptotes. The asymptotes shift as well, right? So the vertical asymptote shifted 3 units to the right, right? So now we have a vertical asymptote here. So what is the vertical asymptote in this function? X equals 3, right? And then it says that the horizontal asymptote shifted 2 units up. So what is the horizontal asymptote in this function? Y equals 2, right? And then now we have new domains and ranges. So the domain cannot equal x, and the range y cannot, in the domain x cannot equal 3, and in the range y cannot equal 2. So remember what I told you, that the asymptotes are going to be guided by your domain and your range. So x does not equal 3. So x equals 3 is our vertical asymptote, and then y does not equal 2. So y equals 2 is our horizontal asymptote. Do you guys see that connection now? All right, so that's all. We're going to continue this tomorrow.